So we need to determine the radius and the interval of convergence for the given series. To do so, we will use the ratio test. So the limit of the absolute value of an plus 1 over an, where n approaches infinity, equals limit of the absolute value. So an plus 1, in our case, it's 2 to the power of n plus 1 times x minus 3 to the power of n plus 1 divided by the square root of n plus 4. And this whole thing is multiplied by the square root of n plus 3 over 2 to the power of n times x minus 3 to the power of n. And n approaches infinity. Let's simplify this. This equals the limit of the absolute value of 2 times x minus 3 times the square root of n plus 3 divided by the square root of n plus 4, where n approaches infinity. Then this equals 2 times the absolute value of x minus 3 times the limit of the absolute value of square root of n plus 3 over square root of n plus 4, where n approaches infinity. Then this equals 2 times the absolute value of x minus 3 times the limit of, here we have the absolute value of 1 plus 3 over n divided by the square root of 1 plus 4 over n. Since n approaches infinity, this means that 3 over n approaches 0 and 4 over n approaches 0 as well. So the limit here approaches 1. So that means that the whole thing approaches 2 times the absolute value of x minus 3. And we know that for our series to be convergent, this has to be less than 1. So that means that the absolute value of x minus 3 is less than 1 over 2. So x minus 3 lies between negative 1 over 2 and 1 over 2. So x lies between 5 over 2 and 7 over 2. So that means that the interval of convergence is from 5 over 2 to 7 over 2.